Hi guys, so today we're going to look at, we're going to continue on Friday's notes, which was, I'm going to scroll to the top, which was on literal equations. So that was what the title looked like. It was when we're solving equations that contain more than one variable. And so we're solving to isolate one of the variables in terms of the other variables. Now one of my classes did example 7 in class and the other one did not. So I'm going to start with example 7. And if you already did it in class, then you can certainly watch it as a review. We're solving for b, and the first thing you want to notice is that there's a fraction in the equation. So the first thing you need to do is clear your fractions. From now on, anytime you see an equation that contains a fraction, is clear the fractions. So you're going to multiply by the LCM, which in this case is 2, because there's only one denominator. We're going to multiply the right side by 2, because that's all one term, and the left side by 2. And what happens is 2 divided by 2 is 1, so they cancel out, and we're left with 2a equals h times a plus b. And we're solving for b, so one thing you could do is you could distribute the h in. Now some of you might choose to divide by h, and that's fine also here, but I'm going to do distributive property. I have ha plus hb, and we're going to solve for b, so we're going to first move this ha to the left side, and I'm going to do that by subtraction. So I'm going to subtract HA from both sides. Remember, division comes at the end, okay? You subtract, then you divide when you're solving an equation. So 2a minus h lowercase a equals hb. And now I solve for b by dividing by h on both sides. So I end up with b equals, and this whole fraction is my answer, 2a minus ha over h. Remember, uppercase a and lowercase a are different. This could be simplified, and that's important for you to know. You don't have to simplify it, but you have to be able to recognize it. This could be simplified by dividing the h twice, dividing the h into the first term, 2a, and dividing the h into the second term, ha. So when you divide 2a over by h, you just get 2a over h. And when you divide ha divided by h, the h's cancel, so you're left with just minus a as part of a separate term, not in the fraction. And that's the answer you would have gotten if, for those of you that up here may have chosen to divide by h, you would have gotten this answer. Okay, both answers are okay. All right, moving on now to example 8. In example 8, we're being asked to solve for m, and one thing you'll notice is that m contains an exponent. It's m squared. So the first thing you want to do is get rid of the 2 and the n surrounding it, and then you'll get rid of the exponent. So think about what you would do to get rid of the 2 and the n. They're both multiplying by m squared, so we're going to divide by 2n on both sides. That's going to get us m squared equals, and I'm going to copy the fraction, a over 2n. So first goal is to isolate the m squared, and then the opposite of squaring a number is taking its square root. For example, 9 squared is 81, and the square root of 81 takes me back to 9. They're opposites of each other. So if I want to get rid of the squared, what I'm going to do is take the square root on both sides. So I'm going to square root and square root. And what that does is the squared and the square root cancel, and I'm left with just m. And then you end up with the square root of a over 2n. So division doesn't work here. This is one of those situations where division is not going to work because it won't isolate the m. Okay, I'm going to ask you guys to pause the video and try example 9. Example 9 should be easy, but then at the end, remember to simplify. All right, so we're solving for x. Oh, actually, typo, we're solving for b. So hopefully you didn't pause the video for too long. Okay, solve for b. So what we're going to do is we are going to try to get the b terms together. So I have mb here and mb here. So I'm going to add 6mb to both sides. So I get the b's together on the left. That'll give me 20mb. And then I'm going to bring everything else down. Minus 6m squared equals 20m squared. Now, since I got the b's on the left, I'm going to get the m squared on the right. So I'm going to add 6m squared to both sides. And now I have 20mb on the left, and on the right, when I add these, I get 26m squared. Right? The exponent just stays there when you add. And now I want to isolate b, so I'm going to divide by 20m on both sides. b equals this fraction, 26m squared over 20m. But then this can be simplified. So make a note, simplify. So think about what number goes into 26 and 20. 2 goes in. So b equals, if I divide by 2, I get 13 and 10. So 13 over 10. And then m squared divided by m, you're dividing one of those m's out from the numerator, just gives me m. So b equals 13m over 10, or 13 over 10m. Okay. We're going to continue to a new type of example, and that is example 10 has a denominator that's complicated. It contains 2 terms. So I'm going to make a little note. I have a denominator has 2 terms. So your LCM, when you try to clear the fractions, is just the same as what you see there, e plus a. It's that denominator. Okay, and there's always invisible parentheses when you have 2 terms. So that's what I'm going to multiply by. I'm going to multiply both sides by e plus a. Now you might be thinking to yourself, but that's going to cancel the e plus a. Well, yeah, but it's going to bring it over to the other side. So these cancel out, but now on the other side you have t that's going to distribute into e plus a. That's another reason why the parentheses are so important, because now that's going to be the distributive property. And on the right side, I just have 2u. And we're solving for lowercase a, which is right here. So to get it out of the parentheses, I have to first distribute. So I'm going to get te plus ta equals 2u. I'm solving for a, so I need to first move this te to the other side. I'm going to subtract it. Subtract te from both sides. I now have ta equals 2u minus te, and now I can divide by t. That's going to get me a equals 2u minus te all over t. If you simplified it, the t would divide into both terms, so I would get a equals 2u over t minus e. Okay, either answer is okay, but you have to understand how to go from one to the other. Okay, and now we're going to learn about a new skill called factoring out. So factoring out is basically the opposite of the distributive property. And we use it as a technique for solving for a variable when it's in 2 places. So I'll show you what I mean. Like in example 11, it says solve for x. And if you look for x, it's here and it's also here. When the x is in 2 separate places and you can't combine them, you wouldn't be able to isolate x. You can't get it by itself. So what we do is we write a problem that looks like this. We take that x and we put it outside of parentheses. I'm going to copy the d equals. And we say to ourselves, like, if I were to write a distributive property problem, x times what would give me px, and x times what would give me fx. And by doing that, you're turning those 2 x's into just like one single x that could then be isolated later. So if I write now d equals, as a second step now, think to yourself, x times what would give you px? Well, x times p is px. And x times what would give you fx? X times f is fx. So now you've turned those 2 x's into a single x, and this is called factoring out the x. And now, since x is multiplying by p plus f, you can isolate x by just dividing. And then you divide by p plus f. I'm going to divide by p plus f on both sides. Cancel, and then divide by p plus f. And my answer is that fraction, x equals d over p plus f. Okay, so I'm going to just read the little top section here. It says that factoring out, we factor out to solve for a variable when there are two unlike terms that contain that variable, when we need the two x's to become one x so that we can isolate it. All right, so again, there was two x's here and here, and I wanted to isolate it, so I factored it out. I put it in front of parentheses and set up a distributive property problem. All right, so we'll look at one more for today, and that is example 12, solve for a. You'll notice again that the a is here and here, so I can't isolate it when it's in two places. So I'm going to take that a and factor it out. I'm putting it in front of parentheses, and I'm asking myself, okay, a times what would give me am, and then a times what would give me a. So a times m would give me am, and then a times positive 1 would give me back a. And now I can isolate a by dividing by m plus 1. Divide by m plus 1, and I now have a equals this fraction, 15 over m plus 1. Okay, use these notes to help you on homework. All right, and I will see you guys tomorrow. Thanks.